Today's lecture is called Behind the Supply Curve, Profit, Production, and Costs, chapters 12, pages 303 to 325. And actually, it's not too bad of a section to look at if you want to, or in your study guide, I'm sure they have a nice summary of it as well. Because you're going to find that there's a lot of new definitions and a lot of curves in this chapter, and that's also why I gave you a handout, so you can kind of more concentrate on just kind of learning the information rather than having to copy every single word down. And you can fill in the blanks as we go, and we'll try to get some better understanding of what these cost curves and what these different definitions are. Because really this is going to help us in the chapters to come when we talk about different market structures like perfect competition and monopoly. We're going to have to know why we put the curves where we do in the next few chapters, and so this is kind of building blocks to learning that. So the learning targets today are the principle of marginal analysis, how to determine the profit maximizing level of output using the optimal output rule, the importance of the firm's production function, which is the relationship between the quantity of inputs and the quantity of output, why production is often subject to diminishing returns, the various types of costs a firm faces, such as fixed, variable, and total cost, how a firm's costs generate marginal cost curves and average cost curves, and why a firm's costs may differ between the short run and the long run, and how a firm can enjoy economies of scale. So we'll look at the short run versus the long run costs. So the short run here is when some costs are fixed. So maybe your machinery or your factory, or if you signed a lease for a land, those things can't change. That's going to be a fixed cost. You can make 0 goods or 1,000 goods, and that's going to be exactly the same cost. That cost is fixed. The output can change, like I mentioned, from maybe 0 to 100 or whatever it might be. You could change that, but you can't change the way the production processes are fixed. In the long run, however, it's important to note that all inputs can be varied and production processes can be changed. So in the long run, if I need a new factory, well, I can do that. If I want to change the lease agreement, I can do that. If I want to get new machinery, I can do that. You can kind of think of the Grebe example that we did in class. If I have more time, I could go out and get more peanut butter and more marshmallow cream and knives. Or maybe I could bring in a new table. So I could do that in the long run. But in the short run, I couldn't leave to go get those things, and so those were fixed costs. But in the long run, all of those things can be variable. We're going to use an example of George and Martha's farm. It's the same example that's in your book, and I grabbed a lot of these illustrations from your textbook. So let's look at the production function here and the total product curve for George and Martha's farm. So it just looks at the number of laborers on the horizontal axis there and the quantity of wheat on the vertical axis. And we can see what one worker would bring in for wheat, what 2 workers would bring in for wheat, and 3 workers could bring in 51, and so on. So you can kind of see that on the graph. So if you added a second worker, it leads to an increase in the output of only 17 bushels. But then if you add a 7th worker, you think maybe they would still be able to add 17 bushels or maybe even more. But actually, they only add 7 more bushels, as we can see by that 3rd column. And so here it says, although the total product curve in the figure slopes upward along its entire length, the slope obviously isn't constant. As you move up the curve to the right, it flattens out due to changing marginal product of labor. And that's that 3rd column there. And you can relate this back to when you learned about marginal utility and how you were looking at the difference from going from 0 to 1 and 1 to 2 and so on. That's the same idea here, but now we're looking at the supply side. And so when we go from 0 to 1, I can make 19 bushels of wheat. So 19 minus 0 is 19. From 1 to 2, I can make 36 bushels of wheat compared to 19. So I added 17 more bushels of wheat, and so on there. And you can see that all the way down. The marginal product of labor, here's just a definition for you. it says the marginal product of an input is the additional quantity of output that is produced by using one more unit of that input. And then there's even a nice fancy little mathematical equation here, which says it's a change in quantity of output over the change in quantity of labor. And again, I think it's pretty easy just to see in that third column on the slide before in your packet there how that happens. So when you go from 1 to 2 or 2 to 3, it's just that change there. But here's the mathematical formula, and you'll have time in your packet that I give you in class to kind of do some of those numbers and kind of figure it out. And then I think it'll make a little bit more sense. What we call this, since there's less and less that more people are bringing in when we hire more and more people, we call this the law of diminishing marginal returns, not too unlike the law of diminishing marginal utility. So it's kind of a similar idea. So the law of diminishing marginal returns, as you can see there, it says it's important. When an increase of an input while holding the levels of other inputs fixed leads to a decline at the marginal product of that input. So what the heck does that mean? Well, if we think about our Greeby example, we kept all those inputs the same. The peanut butter, the marshmallow cream, the knives, the plates, the factory, that was all kept the same. However, what did we change? Well, we changed the labor. So we keep adding an additional worker, and then that's going to lead, we saw that maybe the total productivity increases a little bit, but the marginal product at that point would start to decrease because people start getting in the way and start talking to each other and can't get as much done when everybody's crowded in the factory. Another concept is marginal revenue, and marginal revenue is simply the price of the product times the marginal product, and we're going to find that the amount of an input is optimal and the marginal revenue equals the price. So that's when we would want to, we would know how many people to hire. And apparently that's really, really important. I wanted to show you that again. So there you are. The marginal product of labor, this is taking that third column again that we saw for George and Martha's farm. And so you can just see that it's downward sloping there, the marginal product of labor, and what one worker can do and what 2 workers can produce and 3 workers and so on. And again, that's due to diminishing marginal returns. And there's this first worker employed generates an increase in output of 19 bushels, and the second worker generates 17, and so on. All right, let's look at some cost curves then. And so we'll look at, we talked about fixed cost and variable cost at the beginning of the lecture. Fixed cost is something that you can't change. It might be your machinery, your factory, or your lease. And so it's something that's going to be there no matter what. And the variable might be like the number of workers that you hire. You could hire 1 worker, 10 workers. So it depends on the quantity of the output produced. It's the cost of the variable input. And that input would be most likely what we use early on is we just talk about labor and the number of laborers you would hire. That would be a variable. If we add those two together, we get the total cost. So the total cost is the fixed cost plus the variable cost of producing that quantity of output, and the total cost curve becomes steeper as more output is produced due to diminishing marginal returns. And here's just an example, and you can see the chart below. That's kind of a nice chart there. You can see here you have the variable cost and you have the fixed cost column. Again, remember the fixed cost doesn't change at all. So you could produce 0 products or 8 products here and still 400. So if you're asked to fill in the blanks on a chart kind of like this, which you will in your packet, you'll know that this is always going to be 400. And then this column over here is a total cost. So it's the fixed cost here plus the variable cost. So 400 plus 0 is 400, 400 plus 200, 600, and so on. And so if you take one of these away, let's say if they didn't give you the 200, and they just gave you the fixed cost and the total cost, you should still be able to find that because you would know it would be 600 minus 400, and that would be your variable cost. So in your packet that you'll be doing in class, you should be able to find those missing numbers. But let's take a look at what the total cost curve then would look like. And there you can see it's increasing if we plot each of these points. There is a case in your textbook. It's called the Mythical Man Month. And it says adding another programmer on our project actually increases the time to completion. And it says the source of diminishing returns lies in the nature of the production function for a programming project. Each programmer must coordinate his or her work with that of all other programmers on the project, leading to each person spending more and more time communicating with others as the number of programmers increases. And so what they found was that a project that could be done by one programmer in 12 months could not be done by 12 programmers in 1 month, hence the mythical man month application. And here they just have a graph of the total productivity, and it says beyond a certain point, an additional programmer is actually counterproductive. As you can see on the graph at the bottom there, you see here here's 0. Well, now it's actually going to go negative, so it's going to actually start going negative when you hire even more and more programmers here. So beyond a certain point, an additional programmer is actually going to be counterproductive.